Welcome to FESIG, the free energy special interest group, where science meets spirituality in the quest for truth and knowledge to free humanity and transform this planet into a paradise.
Hi, everyone. Pontus, you got to stop sharing. Hi, everyone. Hi, this is Crystal. I am welcoming you right now to FESIG's 136 meeting. Today is the 7th of May, and this is the second session. We just finished the first session, which is fantastic. Byron Belitsos of the Urantia books has given us a lot of material that we could really think about. Thank you so much for the awesome presentation. So now we're going to start the second session. I would like to share screen so you can see the agenda, because every session of our meetings are standalone. So I wanted you to see, I'm sorry, I have to go right up to the top. Hang on a minute. I'm not finished here yet. I've got to stop sharing first. Okay. I don't know why it came to the last slide of the presentation. Right. So bear with me a moment. I'm going to go to the first. Right. So this is it. Oops. Hang on a minute. Wow. Something's not quite good here. But I'm getting there, folks. So I'm sharing screen again. Share. All right, so today is the 7th of May, and we have the 136th FESIG meeting. So I'm going to big screen it and go along from there. We have here myself, Crystal, chairing the meeting. Co-chair is Dr. Fresprezel, and we have our team members here. We have Pontus, Hendrik, and Jerry, because Matthew's not around at the moment. So FESIG is the Free Energy Special Interest Group, and this is a platform where science meets spirit, and we have our divine mission in setting up this platform for everyone to come and learn together with us so we can move forward very quickly with the knowledge. Knowledge is power, don't forget, folks, in order to achieve our divine mission here in our projects that we have chosen to do. So we have meetings every first Wednesday of the month. Just pen down in the diary at 6:30 p.m. GMT or BST, British time. Okay. So we have we invite every month some of the most brilliant speakers to come and speak here, to share their ideas, their knowledge and everything with us. So it's a wonderful gathering of great minds here. So we have the first session, Byron Belitsos, a leading exponent of the Urantia books. He walked us through the theology and the cosmology of the Urantia revelation and showing us where humanity is heading in the evolutionary pathway, and how we can tap onto the absolute, which is the infinite reservoir of energy of all space, which is so spot on for our group here. And then we have the second session, which we are about to start. We have Thomas Wlazlak. He's the inventor of different types of energy conversion devices into usable power output. So anyway, I'm going to move very quickly now, because every time a speaker speaks, I will give an honorable rendition of their bio to introduce them before they start speaking. So if you want to contact me and you have any ideas how we can move forward more professionally and with better quality work, please volunteer to join us, okay? And help us along, because we are not funded. We have to fund all this ourselves through our own pockets, this whole team here. As I told Byron, we have golden hearts here. We just do it from the passion of our hearts for humanity. If you want to contact me, write to crystal@truevisionofpeace.com. Our website is truevisionofpeace.com/FESIG.html. it's described, all this is all listed out in the description of our videos, okay? Join us, subscribe to all our video channels. It's very important. We need the subscription to get going. And then we have our Facebook as well, so you can keep looking out on what's happening here, so you can join in. Everything is given to you for free for now, until we really completely had no choice but to start a subscription system. But now, please come and join us. Everything's free. Okay, and join our Telegram channel. Our group here, FESIG _group at Telegram, allows you to interact with everyone, so you can start study groups and stuff like that to help you with your work as well. Okay, so now I'm going to introduce our second speaker, Thomas Wlazlak. Okay, so I would like to say that Thomas Wlazlak is one of the most generous scientist inventor ever, because he's always wanted to share, always wanting to share his work with everyone who cares to listen and to partake of the free open sourcing that he's doing. And he's been giving us a lot of information of his developments of his work and all that, with diagrams, drawings, and everything. With our R&D team, the second team, which is headed by Pontus since 2022, right? And we really appreciate you, Thomas, and we thank you for being such a generous FESIG brother, for sharing all your work without any reservation. Not many people are like you, but we really appreciate you. So Thomas Wlazlak is an inventor of different types of energy conversion devices into usable power output. He presents a technology that produces energy without using energy to do so. It uses permanent magnetic energy with 100% unity of its built-in power. The term energy to torque conversion motor, EttCM, energy technology, is what he goes by. And it's Magnagravity concept, where the device runs on magnetic and gravity only. He will show how the testing of the output is done and how the input power works, something that has not been shown before. He will cover the basic concepts of the EttCM magnetic rotor device, which is up Pontus' alley. This is a system that allows magnetic power to increase and decrease magnetic attraction to iron or ferrous metals. The science that says magnetic is not energy, but force. But could they be wrong? So Thomas is asking this big question. Thomas has been generously sharing his thoughts, working paper with us since, at the second R&D team with Pontus at the lead since 2022. So he's our FESIG brother. Hugs to you, brother, from all of us. We are all attentively listening to you now live with your devices. Okay, so you are doing a proposed proof of concept. If an electromagnetic coil can produce an increase in magnetic pull force to ferrous metals when powered on, and a lesser magnetic pull force to ferrous metals when the power is off at a rate of 3.84 times to 1, the ratio is variable. So off you go. You're going to show that, and we're all very excited. Thank you, Thomas. Over to you. Pick up the microphone.
Okay, am I on? I don't have any audio.
Yes, you are.
Yes, you have. We're all listening to you loud and clear.
Okay, do I have audio? Okay, can you see me? Am I on? I can't see myself.
We can see you.
Okay,
you
okay,
look
good. Okay, so what I would like to do is just read a little statement I wrote up first, and then we can go from there with a question and answer period. Q&A period. That's okay? Okay. The energy to torque conversion motor technology is a scientific research project spanning over 55 years study into different means of producing systems that are capable of producing energy from self-contained energy sources. Thousands of experiments and testings were done over that time period to provide answers to what was workable and what was not workable. Each answer added to a collection of knowledge. If one was workable, it was kept, and if it was not workable, it was discarded. In 2001, there was a series of tests that led to a linear motor design that works solely on permanent magnet kinetic energy. The motor is 18 inches long and uses a car that has 6 wheels that is geared on a track for turning over that distance. And actually, the car, I don't have the car in track, but this is the car, and it has magnets on it, just like a regular motor. And so that was a test item that was made to prove that it was possible to use permanent magnet kinetic energy for a device in the future. That was made in 2001. Okay, so over the distance of travel of 18 inches, the one wheel would turn 1.5 turns. In 6 wheels, that's 9 full rotations of the wheel, meaning over 1 turn is free energy. So it had 9. And this technology was called Magnagravity, and that was made from 1999 for the technology that I was working on at the time. In 2018, I discovered a new concept in permanent magnet design that allowed magnetic attraction to ferrous metals or iron metals to be increased or decreased in power. And the means to do that took very little energy. So like a steam engine, the valve could control the output using very little energy, but would be able to produce a lot of energy in doing so. Yep. Okay, the process of evolution formed new technology in the permanent magnet sector, where only permanent magnet energy could be used to produce output power, whereas the energy to torque conversion motor technology uses both electromagnetic and permanent magnet to produce a dual form of energy to produce the output. Whereas the next step is to produce a single magnetic source, which I'm going to be calling energy to torque magnetic. And I did a research on the Google IE to see what it would say about it. And so that, so when I did a Google to the AI, the answer came up, yes, it appears that the EttCM energy technology and the energy torque conversion magnetics are indeed synonymous. Sorry. Both terms refer to a system that utilizes permanent magnet and their kinetic energy to generate movement to work, essentially converting magnetic energy to mechanical torque. This type of technology aims to create a self-sustaining system where magnetic interactions produce continuous motion, which kind of, what I'm trying to do is maintain my research as close to conforming to the laws of physics and thermodynamics as possible in order to allow the scientific community to accept it. Okay. We can go to anybody can ask a question if they like.
Thomas.
Yes.
We need to see a demonstration. You can show a demonstration with a device here. Put the camera onto your device and show it running, please. Thank you. Oh,
that
you need
show?
to talk. Yeah, that's it.
That
Yeah, thank
viewable?
you.
Can you see that?
Yes, we do.
Okay. So this is the test motor for the energy to torque conversion motor technology, which is basically yep. I'm having trouble getting it lined up. Electromagnetic coil and a permanent magnet, and they're basically attached as one. So the permanent magnet is on the back of an electromagnetic coil, if you can understand what I'm saying. So what it does is, I'm going to come back. The electromagnetic coil produces 100% of unity output for an input. And the magnetic permanent magnet produces another 100% output, making it actually a 200% output of one device.
Thomas, I'm sorry to interrupt. You don't have to raise your voice because it's a bit too loud and screeching.
Oh, I'm sorry.
So yeah, if you would just lower your voice a bit, I think we can understand it a lot better audibly.
Okay.
Yeah.
Well, I was
Thank
screaming across the room.
Yes.
Okay, I'm going to go back and just show this device working.
If you hold the
pretty
camera a
excited.
bit longer, then we can see it clearer because it's a bit shaky and blurrish.
Okay, you got that?
Yeah. Yes. Thank you, brother. Thank you. Folks, bear with Thomas because I think it's his first time or second time using a Zoom
Yes.
platform for a presentation. Yeah. It's a jam. Thank you, Thomas. Thomas, you need to speak up so we can see you.
Okay. I'm just
Wonderful.
I'm getting the motor running. Can you see it?
Yes, brilliant. I better keep quiet. So you got to speak up, Thomas, so we can see you full screen.
Okay, it's very hard to see it running, but it is running. It hasn't been ran in probably 6 months. So this is the first time in 6 months this device has ran. Okay. So what it would normally do is run about 600 RPMs. It's running about 200 RPMs right now. But the way it's tested, I'm going to turn it off. The way it's tested is the bearings produce a certain amount of friction. And so I test the friction of the bearings by pulling and turning the motor with a scale. And that tells me how much friction is on the bearings according to the amount of pull that it requires to make it move. And then I can calculate that amount of friction according to the total output of the RPMs that will produce the amount of horsepower it's taking to make it produce that RPM. And then I know the input of the device because the transformer shows me the watts that it's using. The power supply shows me the watts it's using, and then I can calculate the output. And when this is running correctly, it has about a 70 watt input and a 230 watt output. And that's using only 2 coils. If you put more coils on, it will produce a higher output, but because of the design, it will still only use that 70 watts of input. So if it has 20 coils on this device, it can put out like 3,000 watts, but the design will only use 70 watts to produce that output. And that's all produced from using the permanent magnet as the main power source. The electrical power source is just a supplement. It's an amplifier to the permanent magnet energy that it's using as the power source. Is that, can I come back onto the screen now and
Yes, sure. But we would like you to see, I'm sure the audience would like to see the diagram of the makeup of the device that you so freely shared with us for a couple of years now. Do you want to share screen on those diagrams, or do you want me to help you share screen?
Is that what you're referring to?
Yes, I think Pontus can help share screen. Pontus, you still have Thomas
No, I don't have that.
folder. Yes, you have.
All
You
this,
got all of it.
all this information is available on websites. If they look up my name, Thomas Wlazlak, EttCM Energy Technology, they can find all this, all these diagrams, all this information. It's out there. It's freely shared on the Quatora site.
Okay, can somebody
Bettini.
go into the site that I've linked up and share screen? Henrik, can you do that? Can anybody else be the fastest to share screen on Thomas? Because on the website or on the newsletter link, invitation to attend meeting, it's all in there. Yeah. Henrik, bro, can you help?
I can fill in just a little bit while Hendrik is going after the diagrams, if you'd like, Crystal.
Thank you. Yeah, go on then, Thomas. Talk more about your work. I'm sure you're very proud of it, and there's so much you want to share with us and tell us about.
The second generation that I've tested uses a system of just where it increases and decreases. It actually decreases. The increase energy is the same. There's a permanent magnet has a certain amount of energy that it puts out, and that's all. That's unity of the permanent magnet power it has been charged with when it's made, which is a very small amount of energy. It's like 2,000 joules, which is basically 2,000 watts for a split second to produce the magnetic power that it uses or it produces. So the system that I have developed takes and squishes two poles together, two norths. If you put two norths together, the magnetic, I just have a single magnet here, but if you have two magnets of north to north and you push them together, the ends of the two magnets will neutralize each other and it will not be attracted to the ferrous metals. There is, Rossini put a link on there where people can go find that. And did people see that?
I am the home site now. I can share it.
If you link to energy to torque, there it is. Okay, so this device here is that's the test unit that was built in about 2020. And it shows that if you have a south to north, it has a very high amount of pull, but the north to north side has a very weak side. That can be rotated. And to rotate that takes about 1/50th of the amount of energy that it puts out. So if you use that technology in a motor, it will actually, you can rotate that system and it takes very little energy to rotate that, but it will produce a lot enough to make a motor work. Is there I guess we need to shift to another or come back or something.
Oh, can I interject a bit?
Yeah.
I wanted to say Thank you so much, Vinyasi. Vinyasi was the one who interviewed you about a year or so ago, and he's here with us in this group live. Unfortunately, he can't speak up because his microphone's not. Oh, no, sorry, he's in a library. So therefore, but he's been helping in the background. He's been giving a link for us to share screen here, while you expound upon the technology behind it in the diagram. Okay, so here we are. I'm sharing screen for you. There you go. Thank you, Vinyasi. So this is the diagram that you've sent FESIG over the years, actually, and Pontus must have lost that folder with all your diagrams, but I think I saved some. I'll be sharing some later as well. Carry on. So this
So
is
what
the
this
Go
This
ahead.
this shows the breakdown of the EttCM coil, which is basically a coil, a magnetic electromagnetic coil that is in line, or both a permanent magnet and electromagnetic are in the same device. And what this does, if you put 50 watts on that coil, it'll produce about 100 Gauss. If you add 100 Gauss permanent magnet, it'll produce 200 Gauss for the same input watts of 50. So basically it doubles the output wattage without increasing the wattage over unity. So it actually produces a unity of output, but uses less unity of input energy to make that happen. So it really doesn't conform to unity, but it's not over unity either. It's kind of in its own little category of its own. So that's why I called it the EttCM coil technology, because it really doesn't conform to anything. It's outside the realm of both unity and over unity. It doesn't really conform to perpetual motion. It doesn't conform to 0-point energy or anything. It's all its own entity that has just it's just its own entity. So it's really hard to talk about this. Yes.
Henrik has a question.
Yeah, I
Maybe he
wonder
can
if you
prompt
turn
you.
the coil off, then it will still be on, but in 50% of the power, I guess.
Yes. Okay. So if you put 50 watts of power on this device, it'll produce 200 Gauss, but the pull factor is actually 3.84 times. When it's off, it's actually at 1 times. Or in the realm of the test that I did, it's 280 grams of pull off and 1,075 grams pull on, which is 3.8 times more power, which is 3 times the pull force between off and on.
Okay, I got it. Wow.
But that's only for the 2-coil design. If you put 20 coils on, you still have an input of 50 watts, but the output now is 10 times greater at the same 50 watts. So it's it'll put out like 3,000 watts power, but still only use 50 watts to do that, the way the motor is designed. But it's not over unity. Again, it's still the design of the motor is using a concept to where magnetic depletes at the square of the distance. So the distance of on is actually a very short time frame. So it has 1 coil on for a very short time frame. That coil turns off. The next coil comes on, turns on for a very short and a continuing cycle. So it's a very high energy output at a very short time, but constant with the amount of coils you use. And only 1 coil is on at a time, and 1 coil produces all the output power that it produces at one after another. Sort of like a gear. If you have gears, 1 gear only has 1 tooth in contact, but it can put out, 1 gear will transfer 100 horsepower to another gear, one gear at a time. Very short distance. It works, it's pretty much the same way. Is that sort of understandable?
Absolutely. Thank you.
Thank you. So I'm going to stop sharing now while I look for the other diagrams. Okay, so you can see, and probably we can play Vinyasi's recording of the demonstration, right? What do you think, Hendrik? You've seen the videos, right? Press.
Yeah. Basically, I was going to, let's see, do I have my mic on?
You're on.
Okay. I'm having technical problems here. There we go. Basically, when you add an electromagnetic pulse into the system, you're moving from what would be a static magnetic force, as we think of as magnets. They have a tendency to cling together and they don't go anywhere, type of thing, more static. When you add that electrical field to it, you end up adding a current. We call it amperage, and this sets up motion. But the motion is only needed just slightly for a short period of time, because things that are in motion want to stay in motion, and things that are at rest want to stay at rest. So, like I'm spinning the two magnets on each other. It doesn't take a lot of energy to move it, but it would just take a little ping to the system in the line of amperage, or as motion of the electrical force, to get everything moving. And that basically drives your motor. So you're using a small amount of kinetic motion in the line of the current going into this system to start your magnets in motion. The question that I've got is this output to your load, does that affect your motor? So that if you increase the load, does that slow up your motor? We run into this with electric turbines, wind turbines. Do you have the same problem with your motor? Does it do the same thing?
I don't know if I understand the question correctly. The coils maintain a constant amount of force. Mm-hmm. They're not being pulsed. It's constant current being supplied, just like a regular motor would. And so in the coil, in a normal coil, as the motor increases, the current or wattage would decrease as the kinetic energy equalizes the input to the output for the amount of horsepower that it's actually producing. So an unloaded motor would produce 1/10 the amount of the horsepower. Like a 1 horsepower motor would only need 1/10 of a horsepower of watts to run unloaded. But once it starts being loaded up, the watts would increase to keep up with the load. In the with energy to torque conversion coil, it does not do that. The permanent magnet actually forces the motor, forces it to think that it's constantly loaded. So it produces 100% of that output constantly during the time that any power is put to it. So even though the motor is, even if it's running at full RPMs or running no RPMs at all, it's still putting out that same amount of energy. There is no load difference. So if you're running 1 RPM, it still thinks it's running at 100 RPMs. Does that make any sense?
Absolutely
no, it's backward. It's completely backward, isn't it?
Yes, it's backwards.
Yes, but that's how that works. It's actually constantly loaded when it's powered on, but you only need 1 coil running to have 1 coil will produce 6 horsepower output. If that's how it's, basically a 50-watt coil will produce 50 watts of energy for 1 coil, but you're using 36 coils to produce that. But it's only 1 coil running at a time. It's a different system. It's completely different. So one coil will put out the same torque as a 6 horsepower motor, but that coil is 6 horsepower for 1 second, and then the next coil will come on for 6 horsepower for 1 second in a constant motion. One coil only being on at a time, using 50 watts to produce 6 horsepower.
Excellent.
That's something different, right?
Yeah, Pontus, you've been working with this for quite a while. Is there a question that you have that the audience would like to hear about?
Well, when it's powered, actually, if you could do it like a capacitor and you load it every time, you can gain even more energy, Thomas.
It doesn't. I don't use capacitors on it. It's just a straight.
Yeah, I know.
Again, I really don't understand the question. Can you elaborate on what you?
Well, you could reuse the power that you are using and make it a pulsed DC instead.
Reuse the power? Well, it works like a regular motor, to where when you input power, you can take and use the torque for constant motion to run a generator to create electricity, and then repower the system with a portion of that electricity to power the system, so that if the motor produced 3,000 watts of output power, you can run that 50 watts back in and still have 2,950 watts usable, minus the friction of the bearings and such.
Yes, that's of course so. But you could reuse the power that is in the coils that you don't use.
Well, there's only one coil being used.
Mm-hmm.
And all that power is being used to produce the amount of torque to produce the output. But so if you have 36 coils, one coil is on and 35 are off. You really don't need to recirculate any of the off coils because they're off already.
Okay. Yeah, but even if they are off, you still have power in them.
No, there's no power onto them. Only one coil at a time is on. All the rest are not powered on at all.
No, that's not what I'm thinking of. When you energize the coil,
yes,
the power in it, but the power will stay there for a little bit longer, and that you can reuse.
Yes, but that's also used. Yes, you're right, but that's also used in the attraction to the ferrous metals.
Okay. Mm-hmm.
So for the time that it goes off, that it decreases in power, it's also being used a little bit. Yep. So yes, you're correct, but it's not very much. It's not really enough to really,
okay.
Well, that's why I want to ask, how come no capacitors? That the capacitors could add to that, like Stefan Feif's genius invention. Why no capacitors?
It doesn't need them.
Okay, good answer. Okay.
Right. Okay. I'm going to share screen. Some of the diagrams I pulled out from your folder that I saved. Okay. So you can see how it's being put together. Shall I? Okay. So there you go. This is a gyrokinetic thruster. It is not relevant, right?
Yes, that's a gyrokinetic thruster. Yes, that was a part of the experiments that was done a long time ago for reactionless drive, which actually I've gone on past that.
Okay, so we move on to the energy to torque conversion motor, EttCM. This is just you double the image, that's it. So where's the light coming from? Did you put a diode in there? Oh.
That's a spark from the where it has a little armature on it, it has a commutator, which is the way of the power is put to the coil. That's just where it's jumped off of the commutator, and that's the spark that it produces.
Wow, cool. So this is a clearer picture than the video live demo that you're showing. And I'll be sharing bits and pieces, clips of Vinyasi's recording, which is a lot clearer than what you're showing now, because I think your camera's not very clear today. So this is beautiful. Right, this is part of your creation in your home, not to do with the device. Here is the physics of gravity imbalance that were part of your teachings with our group. And is this how it looks like in the design? Can you explain this, Tom?
This is just the concept of the permanent magnet, which we don't really want to get into right now. So we'll pass that one over.
We'll pass that. Okay. And this is a different device.
That's the linear motor. That was the one I did in 2001. That was actually the first working prototype that showed it was possible to use permanent magnets as a power source.
Yeah. As Vinyasi has got some comments on the on the chat. Perhaps okay, I'll read it out because I don't trust some of you reading it out nicely. Okay, so there you go. That's it. So I think I'll stop sharing now. I'm sorry, you're just technologies. Okay, I pride myself as a good reader in school, so here goes. On the chat, Vinyasi is saying that this is why, what you said, the last comment, Tom, that this is why it refutes the silly notion, as physicists used to put in the classroom, that magnets cannot be used as an energy source, right? Vinyasi, I wish you could speak, but thank you for typing out your comments on chat that I'm reading out. So it reminds me of what Jim Murray mentioned during his presentation at the Science, Energy and Technology Conference during the summer of 2013, in which he and a friend of his doubled the frequency, doubled the frequency at a substation of the power grid, and the result was a quadrupling of voltage, causing the substation to blow up after they quickly made their exit. My God, that's dangerous. Tom, so what's your comment on Vinyasi's statement there?
Well, that's interesting because the EttCM coil and magnet actually quadruples the power of the pull factor to the ferrous metals. The Gauss is doubled, but actually the pull factor is 4 times. That's what makes it actually workable. If it was just 2 times, it would be there would be just enough power to make it unity. But because of the amount of 4 times, 3.84 actually on this one, it allows the pull factor to be 3 times greater than when it's on, when it's off. Allows the extra amount of pull to overcome that off stage. So when it's for every action, there's an equal and opposite reaction. So as it pulls into the ferrous field, it has to go out, has to get out of the ferrous field. So the amount of energy going in is 3.84. When it comes out, it's 1. So it has that, there's 3 to 1 times more power to go in and come out. Does that make any sense? Let me do a picture.
Yeah. Go on then. Teach us. Yeah, Tom.
Sorry, I'm quiet. It's just okay. So, yep. Can you see that?
Yeah.
So when it goes into the ferromatic induction, that's a half round is that the ferrous metal. So the magnetic goes in at 3.84, and then when it comes out, it would normally be pulling back in, but it's only at 1 times going out. So on is going in. Going in, it's 1,075 grams, and when it comes out off, it comes out at 280 grams off. Between off and on is that much. But again, where am I at? When you have a series of coils, this coil is on, it goes in. This one, all the rest are off. And so after this one goes in, then this one here takes its place again and comes on, that one goes off. Continually only one on at a time. So one goes on, this one goes off, all the rest will go off. But that one will produce a lot of horsepower being on, because the distance on is very, very short. A 40-watt coil at zero distance, zero air gap, it's called air gap, will produce a pull factor of 500 pounds. At 1/8, it'll produce 1 pound, and then at 1/4, it'll produce almost nothing. So it drops off very quickly. So the way I do it is I take a very short distance, which has a very high amount of pull factor, and that's the time on. Everything else is wasted energy. The shorter you can get that time on period of induction, the greater the power factor. That's kind of the secret to the whole thing. So you have a series of, the more coils you have that are off, that are still doing work because they're on, will produce a more constant output of high energy. Because only one coil is on at a time, only using that amount of energy, it takes very little energy to produce a lot of energy output. Is that it's very hard to explain this. It's kind of a different technology idea. Any questions?
I'm going to jump in real quick to see if we can help out. I can help out a little bit with this. Most of the time when we take a look at coils on motors, we're looking at one coil being turned on and turned off, and the rotor reacting to it. From what I can understand from what you're doing is your commentators, the spark gap it's turning on a different coil at a different time in the rotation, but it maintains that field all the way around for the angular motion of your rotor.
I'm going to see if I have I think I have a drawing of the of a motor that has a multitude of coils, and I can show you I think I have it. Maybe I don't have it. I'm still looking, sorry. Oh, here it is. Okay, so hold this up. If I can hold it up. Can you see that?
Yes.
Yes.
Can you see that all right? Okay, so what this is, here's a series of coils, but the commutator is very short. So basically, there's four brushes on this, and so the only coil that's on is this one here. All the rest are off, but only a short distance of time. And you can see the time on period is from here to here. Because once you get past this point, there's about 1/2 inch into the induction field. There's no more energy that it produces. 1/2 inch inside the induction field is it. After you go in, the rest of the time, it's just pulling straight in. It's like a car being run flat on a flat surface. So everything on this flat surface after this is, there's no energy being produced. The only time the energy is being produced is in the air gap in front of this, and just 1/2 inch inside. After that, it reaches, there's no more energy. Outside of here, from here to here is 0, very little. There's the air gap is a very short distance of power. It's because the magnetic depletes by the square of the distance. You're trying to get as close to that very close point of high energy pull as you can. Anything outside that high energy pull is just wasted energy.
Do you get more out of it? The more that you take, the more that you try to take out of it, does it give you more?
The distance of it's basically about 1/2 inch from the induction field. That's your high input. That's your high amount of energy level.
No,
If you,
I meant the relationship of the more energy you take out of it, does it give you more energy? Because there's a lot of similarities with the.
No,
okay.
It's a constant. Yes, it's a constant.
Very
If the torque of the if the pull torque is 200 or 1,000 grams, that's all the energy you're going to get out of it. Which 1,000 grams pull is about 3,000 watts. And that's for 50 watts in, you get 3,000 watts out. That's not bad. But there's really no limit to the design, engineering, and output of these things. I mean, I have a design that will run basically produce 480 horsepower for a device that's 20-inch diameter and 36 inches long, running on whatever that watts would be. Its comparison to the more coils you have, the better the ratio factor is of output to input. So you can get, yes, Henrik.
Sorry. No, continue till you finish, please.
Okay, so if the like 350 to 3,000, that's like a 60-to-1 ratio. There's no limit to that. You can actually keep going up and get higher and higher, where it's 1,000-to-1 output. And with the permanent magnet only system, that's unlimited output to input. There is no electrical input at all. It's simply all magnetic force output, nothing input. And that is a, go ahead. Now you can ask your question.
Okay.
So you prove science wrong.
Question. Why do you use pull instead of push? Maybe a silly question. And the other one, how do you control the pulses? How do you control when it's fired?
The pulses are controlled through a commutator.
Okay.
Or you could do it electronically, through the same way as a car would do their ignition. It's just basically the same thing. What was the other question?
Why do you use pull instead of push? What's the difference?
Pull is like, I just dropped it. Pull is that. It doesn't. You can't push it off. Push the induction is a. let me see. Yeah, it's being pulled induction. You can't push induction.
Okay.
That's the repel and attract.
Yeah, it doesn't.
right? The
You
North
can't
Pole,
repel
South
from
Pole.
the push of iron. You know, it pulls to iron. It doesn't push
Yeah,
from
of
iron.
course. Yeah, I got it. Yeah, thank you.
Yeah. Jerry has a question. Jerry, speak up. Unmute yourself, bro.
Yeah, I was thinking in that half circle of iron, if you had another set of permanent magnets there doped with a coil, couldn't you get the double effect?
Oh yes, definitely.
Switch them.
Yeah, in fact, you can divide those half circles into half circles and have two half circles, and you double the output. Of course, you double the input too, but then again, you can keep going and going and going until you have a machine that would have every coil on it every time, constantly for little tiny periods of induction.
Thanks.
But it would have to be water cooled because they get very hot. Or some type of cooling system, yes.
Use it as a boat engine.
Yeah, exactly.
Just kidding.
Yeah, I need to share screen a bit on some of the material. I pulled out conversations with Thomas in case you think that you left out certain stuffs. Okay, here we go. I don't know. Oh, there you go. So in 2017, I pulled this up. You saying that a fraction of a milliwatt over 9 hours is not much in line of power. How close to some radio tower to get a milliwatt bleed in charge do we need to be, not to get off subject? What if there were a real big output device that could generate power 24/7, 365, and let's say 25,000 watts, or how about megawatt? So Corinne Technical Design, EttCM Energy Technology, Washington. Since 2017, you've been proving the concept, right?
I've been doing this, the concept of EttCM since, a long time.
Okay. So you were saying 25,000 watts that it could generate?
Actually, that's actually small now. Back then it was big, but now it's small.
Right. Okay.
And not the 9 milliwatts is basically what people were pulling off of radio towers for like crystal radios and things, and they were using that for their to get the idea.
You wrote to me just some days ago. You said because no one will really understand how the concepts work, that is a one-on-one personal endeavor. This technology is a world-changing event as it produces energy without using energy to do so. Because the technology uses permanent magnetic energy, it is 100% unity of its built-in power. It uses the term EttCM. Okay, and it's also E equals Cm, that is E equals energy, C equals time, speed, and distance, M equals mass or weight. This is the real formula for calculation, you said. So energy saying if E equals 2, time equals 1, speed equals 1, and distance 2, and mass equals 1, 1, 1, 2, 1 equals 2, energy equals 2. This is real. Einstein's E equals mc2 using Einstein 1112 squared. So would you explain this to our team here?
Well, the actual formula for energy is it's time, speed, distance times mass. Whereas Einstein's theory said it's the speed of light squared, where speed of light is the same as time, distance, and speed. Only he said it's squared. So, but if you square that, you get actually twice as much as you should have. So, but what Einstein was saying is that the his formula deals with slowing down this as matter speeds up, it actually time slows down. So his formula deals with the relationship of my mind went blank. I'm sorry. As time speeds, as you speed up, time slows down. That's what Einstein's theory of relativity is. Mm-hmm. That's the E equals mc squared, but it really has nothing to do with the actual calculations of horsepower as we see it. It's, his relationship's different.
Right. I want to show now this before we continue with the Q&A, and then we will have to close down soon. So this is Vinyasi. This is the video recording you did with Thomas, and this was done just last year, wasn't it? A year ago. Yeah. You had 350 views, but we're going to get a lot more views here for you. So this is a lot clearer.
Let me get some light, more light.
Can you hear the sound? If you can't, I'll stop sharing and but because this is a lot clearer so folks can understand what your device is about. Okay.
Gustav, you can raise the volume a little bit.
Raise the volume. Okay, hold on a sec. I cannot optimize video for sharing. Yeah. Anyway, you can hear. Yeah, I will put the volume up. Yeah, I put it to the loudest. All right. Okay, here it goes.
But I mean, it's got two copper plates and a coil.
This is Vinyasi.
There's a coil here. Let me get it a little higher so it's a little easier to see.
It's still running, but waiting for Thomas to start the machine.
Hopefully my computer doesn't fall on the floor. Okay, so can you see that?
Well, sure, I can see it like before.
Okay, so basically, here's a coil here, and then there's another coil on the other side. There's two coils.
Oh, so that drawing only pertained to that coil.
Only pertains to this coil of how to assemble just this coil.
Oh, okay.
The motor, I got drawings for the motor too, but I didn't send that.
Well, you sent me drawings like 8 or 9 months ago.
But probably not of this motor. This was built in It was built and tested in December 22.
Right. Yeah. That's when you sent me drawings.
Okay.
And also in the spring of wasn't it the spring of last year and then December of last year?
Could be.
Yeah.
Could be. So anyway, what this motor does is it's just basically an induction motor. So it's just basically it draws it into iron. So this spins like this, pulls it in to an iron plate. Let me see if I can show that.
So you don't power this; it just spins.
I do. I power it.
Oh.
So it basically runs on 35 watts, and I'm using the friction of the bearings to calculate how much power it actually produces. So what I do is I did a pull test on this shaft here, and I can calculate that it takes about 0.32 foot. Well, let's see that. Yeah, 32 pounds per foot of travel. So if it travels at a certain speed, a certain RPM, it'll produce a certain amount of watts. It takes a certain amount of watts to produce that. So let me just turn it on for a second. It's kind of neat to watch.
Do you have?
So it runs on this power supply here, and
Are you making contact with the motor using you scrape
Brush.
it at 2 wires across the
Yes,
top?
there's brushes here. There's brushes on both sides and a commutator on the wheel. This will all be shown later. I'll show you all this in in drawings later. But this is basically just for a show and tell thing.
How much boost do you get with that magnetic shielding covering half the diameter or circumference?
What's that?
How much boost do you get with that shielding covering half the circumference?
I'll have to ask that again after it stops.
Oh, it's making noise? I don't hear any noise.
Right now it's running 641 RPMs.
Okay.
And it's running on about 85 watts, maybe 90 watts. Okay, so right now it's running on 90 watts. It's running at 686. I'm going to turn it off. Okay.
Yeah, I'm curious what those bolts are surrounding the circumference.
So that's it. I think that's all the demonstration clips that I could get hold of, Russ.
Okay.
Yeah, that I'm sharing here. It's for all to see. Yeah, so you get a lot of viewers from here. Thank you, Vinyasi, for making that video with Thomas much earlier. Yeah. Go on then, Thomas. Is there anything you want to add to that?
I was going to do a calculation on that 618 RPMs. I mean, 618 RPMs at that pressure at that time. 18 times 0.31. I'm doing a calculation. That was at that time that was producing 260 watts at about an 85 watt input on that experiment. 280 watts on 85 input. It's pretty good.
It is. What say you, Russ? Henry? Pontus? Jerry?
Yeah, that is good, of course.
Yeah.
That's a 300% less input than output.
Oh, Graham is here as well. Billy, sorry, I didn't ask you. Graham, Billy, Scott, Metis. So you guys speak up. Come on, interact with our brother here.
All righty. I'm going to show what usually is a magnetic field with a motion. And this one's doing from the underside. Doesn't matter whether you put it on the top of, these are three magnets. But you get an oscillation. And it's one bit of energy, and then it has to sustain back and forth. This is the dampening. And it's because of the fields repelling. In the case of his motor, he is not charging the shield. He's working with the attraction. So it'd be starting out a little bit past the edge of the metal shield. And that's what's instead of it being a magnet, it is a piece of iron. But the charged magnetic field is not just a permanent magnet. It is also electromagnet that is boosted just slightly. So as you go past that or leading edge, you get the acceleration. And it goes across. I say you can run this thing either way, but you're instead of dealing with a bipolar, two different, north and south, you're running a single pulse, and it's carrying through that piece of metal to make the spin. So it's quite efficient in what you're doing, and you're only parting part of it, and you're allowing the residual to to go through? Am I helping or am I confusing people?
Actually, that's not really correct.
Okay.
There is no residual after it enters the field. It actually you're pulling toward it when it reaches the top of the top, that's 0.
Mm-hmm.
So as it pulls in, it goes this way, but it's also from here back, it's pulling backward. So from this way, it pulls this way to this point, and from this way, it pulls this way. But once you get past the point of 1/2 inch here, the amount of pull factor is almost 0. The only real energy you have is that air gap where it's in front 1/2 inch to 1/2 inch in here, which is actually the this whole area here is your induction force pull of attraction. But once you reach to here, it's 0 because it's trying to pull back the other way. It's like almost like Earth's gravity pulling to the center. But
Excellent.
but there's really this induction field does nothing. You could actually have a induction field only 1 inch long, and it would do exactly the same thing. I use half because it was easier to build the motor that way.
Okay. Yeah, what I think we're talking past each other, but the concept is it's at that cut edge, that 1/2 inch, where you get your maximum acceleration.
If you hold your hand apart like this for your magnets and you move them in slowly, at a certain point you will not have enough strength to hold it apart. That's that minimum air gap.
Yep.
Boonk. You know, it's like here it has no energy. Closer. Pretty soon you don't have enough strength to hold it. It's going to pull. You know, that's that air gap. That's that minimum air gap where the most amount of energy is produced, and that's what I'm using. That little tiny bit of gap.
Gosh, you're a good teacher. Yeah, and I think Vinyasi was saying finally he understands how your motor works now.
Oh.
Well done. Thank you.
This is Scotty.
Like I said, it's very complicated to understand that little tiny bit of, that nobody ever talks about that. Okay.
Well done. Scott, go on then.
Yeah, I was a little unsure until I saw the clearer video of that with that beautiful blue steel thing. So I really have to see more of it. So you're saying those 2 coils that move freely, that the center of them is actually also a magnet. It's not just an electromagnet.
It's an electromagnet, and if you look at the motor, you can see the end of the, there's a silver sort of thing on the end that looks like a washer. That's actually the magnet. It's on the end, not in the center, but the end.
Oh, so it has steel and then a capped magnet on it, plus it also has a coil to make an electromagnet.
This is the coil. This is basically the same type of coil that's on the motor.
Just larger.
So the magnet is on the end like this. And then this is attached to the black rotor part. And then on the outside here is your work end. And that's where the ferrous induction field takes place on this end. The magnet's on the other end.
Where is the heat created that the other guy said, well, you can make heat with it also? Where is the heat being created?
The heat is in the coil itself because it's producing sorry, my brain went dead again. The magnet is almost like a motor being fixed. If you fix a motor and don't let it turn, it'll produce eddy currents.
Like
the eddy currents will cause, right. The eddy currents inside of the coil, a motor that is not turning, that is fully loaded, will heat up like crazy. If I just have this coil and turn it on and leave it like this, it'll burn itself up in a minute. And when you put the magnet on there, it's almost like it's a loaded motor. Putting a constant amount of current for the watts input will be putting like it's a full load, stagnant, moving motor. So it's like you just hold the shaft from turning, all the coils will burn themselves up quickly. A motor has to turn in order to release that energy.
And if the over unity factor and the on unity factor isn't enough to void the warranty, did you also hear us talk about anti-gravity somehow involved in that?
There is no anti-gravity. No, it's just
Okay.
straight physics. There's
Okay,
nothing.
well, I
It's
just heard a bit of that, but I just want to add a few things that I think Fraz maybe can elaborate on. But the Stefan Fife that I mentioned earlier, he created a similar thing that worked one at a time. Like when you drew the picture with the circle, it goes one, one, one. He compared it to like buckets of water. You're just pouring the 5-gallon buckets from one bucket to the next, but it was one at a time thing going around. He did it with supercapacitors. He called it the flux capacitor, but he definitely was tapping into something else, because the more he took out of the device, the more it gave you. And that was just a gray area that maybe Fraz can elaborate on. And I'll get you his stuff to look at too. He made that open source.
Yeah,
flux
Scott,
capacitor.
we will get Stefan Five. He's our, FESIG brother right from the beginning, earlier days. We'll get him back to speak, okay? Thank you for pointing him out as well.
Very, very
Thank you
good.
for
Thank you.
Gunnar Fress.
Oh, it's fine. You get it. It's two different modalities. Stefan's work is all in capacitors, and Thomas is working with inductors and iron and permanent magnets. Different concepts.
Well-
it's similar though. If you think about it, the capacitors produce a large amount of output for a very short time. But yet you still end up with the same unity of output. I don't know. I have not researched that, so I don't know what he's doing. I would have to see his research to see what the difference would be.
Yeah, it'd be nice if Stefan's coming back, and we will get you in as well so you can compare notes, yeah?
Yes.
Oh, yeah. Thomas, you're one of us anyway. I mean, don't stand on ceremony here. If you need to speak with any one of us, here I am to connect you through, okay? And,
Okay, thank you.
Yeah, you are in team 2 with Pontus. Don't know why Pontus didn't ask you to come back to do any demonstrations, but here we are today. Well done. So, are we done with the discussion? Can I just wrap up everything, because it's ongoing for quite a while now. We can't have too long a video, Fraz. What do you think?
I think so. This is a good place to wrap it up. And thank you so much.
Can you put
Thank
that
you.
video in the chat, Crystal, that you played?
Yeah.
The clear video?
Can I what? Say that
Put
again,
the
Scott?
video that you played, can you put it in the chat?
I sure will. I think
Thank you.
Henry can put it there in the chat as well, Henrik, while I wrap up the meeting and close,
think it
because
was
I'm
in
going to take a
the-
while to do it. Yeah, you remember I placed the link in the mega groups, team 2 and the core team. Yeah, and not team 3 or whatever. We don't have that. Okay. Yeah. All right, so we got it in the 2 teams, yeah, the group chats. You got it? All right, now, so there being no other business, now the second session of the 136th FESIG meeting is now adjourned to the next meeting, which is the 137th meeting, I believe, and that will be 137th FESIG meeting will be on the 4th of June. Please pen down in your diary, folks, so you don't forget to attend the meeting. We always learn so much, and we are so blessed with brilliant speakers like Byron, Thomas, Wlazlak, Inventor. This time round, but there have been many illumined speakers as well. And we are so lucky to be learning together like that. It's so good. Thank you. We can stop recording, please. Thank you.